Okay, I'll wait for other people to join. We still have a few minutes to go, and we'll start the class at 4. Okay, so I think we can start the class. It's 4 o'clock. So today we have a new topic which we'll be starting with, which is consumer theory. And it's a very fundamental and important concept in the world of microeconomics. So if you have any questions, first of all, like from any of the previous chapters or from consumer theory itself, uh, you can let me know so that I can either answer it beginning of the class or I can answer it as we go along. But if you don't have any questions, I will just go ahead with my questions, and these are just to help you sort of understand the material a little better and to help you with answering the problems and do the exams and stuff. Okay, so any questions from the previous chapters? No? All right. So let me go ahead then. So the first question is which of the diagrams in in the slides, which of them represent or can represent a consumption set? And there are certain mathematical conditions or certain mathematical requirements which consumption set must fulfill to be a consumption set. Without that, it's kind of, it cannot be a consumption set. And you may think that these mathematical requirements are not making sense, or this is not really why should this be required, blah blah blah. But see, a lot of the stuff we do in economics tends to be very mathematical, as you might have seen already, right? So these mathematical assumptions or conditions are important so we can do that mathematical reasoning or do that mathematical analysis, right? So even though, like, sometimes it may feel like these conditions which we're imposing on the consumption set, they are just purely mathematical, why do we need it? But as we go along, you will see that there is actually a rationale behind it, and the conditions are really just capturing that rationale. Okay, so okay, the screen needs to update. So these are the four diagrams. This is the first two, and there's a lag actually in the screen updating. Yeah, these are the next two. So if you want, you can also draw it for your own selves. Excuse me, I have a cough and cold, so I will be coughing throughout the class. I'm sorry about that, but there's nothing I can do. Um, so you can see figure A, B, C, and D, or I can make it smaller like this so you can see all. You can see now A, B, C, D. Which of these diagrams do you think can represent a consumption set, and why? Why should some of them represent and why shouldn't the others? So that's the question. You can answer in the chat box which ones do you think can represent a consumption set. Just answer that question. And why would they represent, whereas the others won't? So there is a really important condition on the consumption set which decides these things. So normally the consumption sets you guys might encounter may not be of any of these weird shapes, but that condition is important, and it's important for all of you to understand how to apply that condition, not just mathematically but also sort of geometrically. So anybody wants to answer which of these diagrams can represent a consumption set? No? Okay, so let me go ahead and explain this then. Okay, fine, blue is fine. Okay, so one of the important conditions of a consumption set being a consumption set is convexity, right? Like the set needs to be a convex set. And what do we mean by a convex set? Let me draw this here actually. So what we mean by convexity is that, say suppose there is a consumption set C. We are saying that this is a consumption set. Now if say x1 and x2, or we can call it something else, let's say because I've labeled the axes as x and y. So let's say if A comma B are two consumption bundles such that so A and B are two possible consumption bundles such that they both belong to this particular consumption set. Okay, and we are calling this is like a two good world. All this analysis at your level is considered in a world which has only two goods. Okay, so say suppose this is a diagram. Okay, this is x, this is y. These two goods are x and y. There are two sets. Okay, this is A. You can say x1 comma y1 and B x2 comma y2. I'm just trying to use a notation which is less confusing. Okay, so say suppose these are two consumption bundles. You know, if you this xy is confusing, you can think of it as say chocolates and cakes, right? X is chocolates, C is cake. Sorry, Y is cake. Then you know you are having two chocolates and four cakes versus you're having three chocolates and three cakes, something like this. That's what x1, x2 over here are. Okay, so these are two consumption bundles and they belong to this consumption set. Then convexity implies that if there is any number t which belongs to 0 comma 1, the interval 0 comma 1, which means it is any positive number between 0 and 1, including both, then if there is another consumption bundle, there is another, all this is there I think in your lectures, but I'm still just recapping it. Say D such that D is t times A plus 1 minus t times B, then D will also belong to the consumption set C. What are we trying to do here? What we're trying to really say is that if you take A and B in some proportion, you know, proportion meaning like you've taken a certain proportion less than 1, of course, and you have taken B in the remaining proportion, which is 1 minus t, t and 1 minus t, and you take any combination of two bundles which you already know are there in the consumption set, then that third bundle is also going to be in that consumption set. So say suppose, need not geometrically always be in this place where I'm putting it. Say suppose this is the third bundle, D, and this is your t and 1 minus t, kind of a linear combination. Then this D is also going to be a part of that same consumption set. What this means for us geometrically, which is the more important thing here, because I asked about which of the following diagrams can possibly be a consumption set. Now, this mathematical analysis is just to give you a recap of what convexity means mathematically. I mean, geometry is also maths only, but I mean like diagrammatically, what it means is, say suppose there is some weird shape of a consumption set. This needs to be a little better. Why I'm correcting this, you will understand in a minute. Now in this, if I'm not saying that this is a consumption set, I'm saying if this is a consumption set, then at any point, if you take any 2 points on this consumption set here and here, right? And you join these by a line, then this line should lie completely inside that set. That is the meaning of convexity, because any point on this line, say suppose there's this point on this line, right? This point can be considered to be a linear combination of these two other points, this point and this point. So these other two blue points, let me make this point in some other color too. Yeah, so the two blue points are within the consumption set, right? Let me mark them in a similar way what we discussed, A and B, right? If A and B are in the consumption set and we take a weighted average or a certain proportion of A and certain proportion of B, such that TA plus 1 minus T into B is another consumption set D, then D should also be within the consumption set, right? Now, but in this particular shape, D is falling outside this shape, right? What is the shape? This is the shape, but D is outside it. So that means this cannot be a consumption set. Let me highlight this also so you can understand what I'm referring to, although I think by now it's kind of obvious. You know, so this is your consumption set, okay? But if you connect A and B by a straight line, this point D, which I have picked, is falling outside it, which means it's not in the consumption set, which means that this diagram or this particular shape cannot possibly be representing a consumption set, because in a consumption set, if you take a linear combination, a weighted average more like, of any two known consumption bundles, then the weighted average of them also belongs to the consumption set. So now let's go back to the diagrams which we were discussing. These are the diagrams. Okay, this is A and B, and this is C and D. So now you have to answer which ones do you think can be consumption sets and which ones can't be consumption sets. So I hope the concept of convexity is clear, whatever I explained so far. If you have doubts, you can ask me now. Whatever I mentioned as the sort of like the definition of convexity. Yes, no, it's not clear, you can tell me. If it is clear, you can just say yes. Okay, somebody has answered. Okay. Anybody else? Good. Anyone else wants to try? Can someone explain also why A and C will be convex? It's not that difficult actually. So just remember, if you want to check for convexity, there's a very simple thing you need to do. And after, I don't want to recognize text. How do I make this go? Okay, just ignore this pop-up at the bottom. So there's a very simple test for convexity, geometrically speaking. You just see if you can join every point on the curve, and if all these lines joining different points on the curve are completely inside the shape or they're outside. So in this, you can see you can join any point to any point on this shape and the line is completely inside, right? That is what convex means. In this shape, these lines are probably all inside, but what happens if you pick one point here and one point here? And this line is outside the shape, right? So that means it's not a part of this shape or this set. So this cannot be convex. This is a triangle, so this is pretty straightforward. This obviously you can take any lines anywhere. They're all going to be inside. Now this donut is also a pretty straightforward. You can take any point here and here, then the line is falling outside. If you take a line inside like here, then it's fine. But if the line is falling outside, it cannot be okay. So D will also not be a convex set. Okay, is this clear? This logic, this rationale? Okay, great. So again, I'm sorry, I have a cold and cough, so I will be coughing a lot throughout the class. There's nothing I can do about it. But to save you the torture of listening to me coughing, I'll mute myself now and then. Okay, so I'll give you a few minutes to read the next question. This is just the introductory part of this question. This question has several parts, which we'll go to one by one. So first of all, I mean, I can read it aloud, but it's better if you read it yourself. Yes, I think somebody wants to say something. You can ask me a question if you want. You're allowed to unmute and speak also, or you can type it in the chat box. I don't mind. Charpa Uma Maheshwari, you want to ask something? Okay, so let's move on to the question. So all the books and coffee here cost the same amount, and you're given that Avery has a budget of 2,000 rupees. She can either consume only 5 books or only 40 cups of coffee in 1 week. This is a weekly budget, right? It's a weekly budget. So what is the price of 1 book and 1 coffee? This is pretty straightforward. Did anyone solve it? Right. C is the correct answer. How do you solve it? So you're given that if she's consuming only 5 books, like the budget is 2,000. So if she's consuming only 5 books, means she's using up her entire budget just for books. So that means the price of 1 book is 2,000 by 5, which is 400. Similarly, if she's consuming only coffee, then we know that with that entire budget of 2,000 rupees, she's buying 40 cups of coffee. So 1 coffee is 2,000 by 40, which is 50. So C is the correct answer. This is the easy part. Now, I've made this question so that you calculate things kind of like step by step, so you're not kind of rushed through it. And now you have to calculate the budget equation for Avery. So what do you think it's going to be? Or more like, how do you calculate it, first of all? Okay, somebody's answered. Anyone else wants to answer? Or is that it? Okay. How do you get the answer? Does anyone want to explain? Venture and explain that? Okay, so I will solve it here. So the budget equation is just basic. If you forget, we're studying microeconomics, blah, blah, blah. If you just think of how you do your budget, right? You have one item which costs a certain amount, P1. You're buying it in the quantity X1. And you have another item which costs P2. You're buying it in the quantity X2. And your total budget is, say, I. And you're using up your entire budget. Then how can you express it mathematically? Normally, what we have is it will P1 X1 plus P2 X2 is less than or equal to I, right? Because you may not use up your entire budget, right? But in this particular situation, you are given that you are using the entire budget. So we can just go with the equality and forget about the inequality. Now we know P1, or you can say PB, the price of books is 400. PC is 50, right? So what we will do is, and we know I is 2000. So therefore just plug in the numbers and you have 400B plus 50C is equal to 2000. Now you can just divide it. Uh, this is divided by 50 is, no, sorry. Oh, it's right actually. So this is your budget equation. I don't remember which option it was. Yeah, it's D. So either you can, so the reason why I think sometimes people confuse this part is that whenever you're writing a simple equation, if there are any common factors, like how we divided here, we divided the whole equation by 50, right? So when you divide the whole equation by 50, you get this final expression 8b plus c is equal to 40, because the whole equation is divisible by 50. If you want to keep the right hand side as 2000, then the left hand side also needs to be 400 and 400b plus 50c. So the proper way of writing a simple equation is taking out anything which is common in the whole equation. Why are you telling me your Insta ID? I don't need to know your Insta ID. I just want to make it clear that this class is only for this particular course. Please do not bring any of your personal stuff into this class. Neither am I interested, nor should you be interested. And I will not entertain any questions outside of the coursework in the class. And if you're not interested in the coursework at all, you are welcome to leave. I'm not an entertainer, I'm a teacher. Okay? Let me go back to the question. So this correct answer is D here. Next, we draw this. So this, I didn't draw it, but this is the simple diagram for it. You can just take the intercepts based on this equation now, right? We have this equation, 8b plus c is equal to 40. You plug in the value of c equal to 0. You get the value of b as 5. That's the intercept on the b axis or the y axis. And you plug in the value of b as equal to 0. You get the value of c as 40. That is the intercept on the c axis. It's a pretty straightforward thing. And why have we shaded this whole part? Because this is the budget line. But this shaded part in this diagram, that is the budget set, right? The budget line is the upper boundary of the budget set. What we mean by budget set is that Avery can consume anything, like realistically, she can consume anything in this entire shaded area. All of that is possible for her to consume because this shaded area, first of all, it needs to be a consumption set, right? Next of all, it needs to be a budget set for her, for it to be feasible for her. So the budget line is defining the upper limit of the budget, right? So on all points of this budget line, her budget is going to be I. Let me draw this. Oops. Okay. So here, if whether you take this point or this point or this point, the budget is still I equal to 2000, right? On each point on this line. But this entire set is the budget set. Okay, so there may have been some other boundary. Oh, this changes the color for everything. Okay, anyway, you can say suppose there is another line here somewhere, and this whole thing is your consumption set, but the whole thing is not your budget set. The budget set is defined by this line, which is your budget line. That is the reason why you need to know the budget line or the budget equation for any kind of a consumer theory question, because only these points in, okay, this is, you understand what I mean, right? This is a little bit outside, but yeah. So all the points here, this shaded area, they're all part of the budget set. Okay, let's go to the next question. This question has several parts. So, okay, this I don't think you need to calculate, but sure, if you want, you can go ahead. What happens if her weekly budget is doubled, but the price of each book and each cup of coffee is also double? So what do you think is going to happen? Okay, so let's see what happens. Let's draw this and write this mathematically. Let's do this step by step. What is the question number 4? Okay, so in question 4, we are saying that the new price, say we call this PB prime, is equal to twice of PB, right? And we are also saying the price of coffee is changed. So this is twice of PC. And we are saying that the income is also changed. So this is twice of I, right? So far, so good. Now what happens? We just write the budget equation like we did before, right? There's no change in the methodology. We write PB prime to B plus PC prime into C is equal to I prime. That's the new budget equation, right? Yeah. So I'll come to what happens if the price is changed or if the price is not changed also. But for now, let's just see what happens if everything is double. So now in this case, let's plug in the values now from before, whatever we've written. We know the values of PB prime, PC prime, and I prime. So this is 2 PB into B plus 2 PC into C is equal to 2I. Now, like I was just explaining in the previous question, we can just remove this 2, 2, 2, and this becomes the same equation again, right? This is, again, we are back to the same equation. Now let's draw this and see what else can happen if we change only the prices or only the income. So say suppose I draw this diagram here. We're taking C on the x-axis, right? Okay, this is 40 and this is 5. Please remember my diagrams are not exactly to scale because that's pretty difficult to do. So, okay. Okay, so this is your original diagram. C intercept is 40, right? Yeah. Okay, so now in this case, say suppose the prices are increasing, right? And the income is not changing if both the prices are increasing. Or let's go one by one. Let's say only the coffee prices are increasing. Now, if only coffee price doubles, we have PC prime is equal to 2PC. The rest is the same. The rest is as before, right? As before, meaning in the original question. So you have PB into B plus 2PC, right, into C is equal to I. Now we can't really cancel out anything because there's nothing to cancel. PB, we plug in the value 400 B plus PC was 50. Now this becomes 100. C is equal to 2000. Now we can cancel. Now the equation is different. It's 4B plus C is equal to 20. Right? So you see, if you change the price of only one commodity, then the equation is changing. And why is that? Because now you've increased the price of coffee. So for the same amount of money, you can consume half as much coffee, right? So if the price of coffee is now $100 and you have 2000 rupees budget, you can have only 20 coffees, whereas earlier you were getting 40 coffees. That's all it means. So here now, if the price is changing, this is where 20 is, right? And in this equation, again, if you want, you can plug in B equal to 0, you get C equal to 20. So the intercept is much lesser on the C axis. So now the new budget line is going to be this pink line. It's not going to be this original line. Similarly, if instead of, say, changing the price of coffee, we change the price of books, not coffee, only the price of books is doubling, then the y-intercept is going to change for just books, not the coffee. So the coffee intercept is still 40. For books, it becomes, say, 2.5. Books are becoming $800. So then this is your budget line, right? Now, in our case, there's one more scenario we have to consider before we go to, back to our case. In this scenario, say suppose both the prices are fixed, but the income is doubling. Then what happens? Prices are the same, but because the income is doubling, you can consume twice as much of both the items. So let me delete this and extend this a little bit, even though it will still not be like proportional, but okay, we can try. So this becomes, say this is 10 and say this is 80, right? And oops, this becomes something like this. Why is that? Because now you can buy twice as much of both the items with your current income. So you suddenly had some extra income or something, and you can make, like, you have much more money to spend on both the items. So this is what happens in the scenarios where only one or of the items is changed. But in our scenario, just to make sure that you actually understand what we're doing, if we change the prices and income all by the same proportion, then the equation remains the same. Even in this, if say suppose I change the income by a different proportion or one of the prices by a different proportion, it will not remain the same. It will be a different equation then, right? So, and how will we calculate that? In the same way. So if the price is increasing, you just change the value of PC prime to whatever the increased value is, and the value of I prime, whatever the increased value is, and whatever comes out to be the new equation, that is your change budget equation. So you may get some question like, if the price of coffee is doubled, but the price of books is 4 times, without the income change, what happens? So you can compute all those things, right? It's just a question of a mathematical detail. Okay, so we've gone over this. Now let's go to the next question. Now her doctor is advising her to ration her coffee consumption, and she's told to not have more than 20 cups of coffee per week. So now you're asked to redraw the budget line for this scenario. And then you also have to calculate what is her consumption of coffee if she's consuming 2 books. Okay, so I'll give you a few minutes to think it over, how you will calculate this or how you will draw this. And remember, this time her income is not changing. It is just there is some external factor, some constraint because of which she is forced to not consume more than 20 cups of coffee. So I'll give you a moment to think about it. So any thoughts? Okay, we'll come to the second part of the question in a bit. Um, First, we need to redraw the budget line for this scenario. Okay, let me okay, it's not exactly straight, but you can understand what the diagram represents. So what happens here? Like basically the diagram is essentially not changing in terms of mathematically. Right, good. So somebody's answered in the class. So this is the point where say C is equal to 20. And let's draw a line here. And this whole part where, you know, C is greater than 20 is not going to be a part of the consumption set or the budget set anymore. So only this part, this green part, which I'm highlighting here, only this part is now going to be the budget set. You can see this, right? So this part is the budget set now. The part which where C is greater than 20 is not part of the budget set anymore. So this is removed, right? Now let's see what happens when B is say equal to 2. Our equation is basically the same, but there is one condition we will add to the budget constraint. The original equation was what? 8B plus C equal to 40, right? 8 8B plus C equal to 40. Now there is one condition here such that C is less than or equal to 20. So if you don't write this condition, you are missing out on the whole, mathematically how you are going to represent this condition. Without this equation, your answer is incomplete, basically, right? And when you're computing it, for example, now you're given the value of B as 2, right? So if we plug in the value of B equal to 2, what do we get? 16 plus C is equal to 40. C is equal to 40 minus 16 is 24. But we know that C is less than or equal to 20. Even though now technically, budget-wise, Avery can consume 24 cups of coffee. But because of this constraint which the doctor has imposed on her, she cannot have more than 20 cups of coffee, right? Therefore, for B equal to 2, C will be equal to 20. That's the reason why this part was there in the question. So to see if you understood what this kind of mathematical representation means. So even if you draw a line here, B is equal to 20, you can see that this intersects the curve here at the point where C is 24. But even from the diagram, you can see that that point of intersection with the original budget line is outside the new budget set. The new budget set is this shaded part, which, well, actually on the dark background, you can't see it properly, but you'll see it in the file which I share. So this part, that C is equal to 24 is outside this part. Therefore, it cannot be the value. So the maximum here we have a hard limit is C equal to 20. So it's going to be C equal to 20. Let's go to the next question. Yeah, this is the diagram. I have it here also. It's the same thing which I drew, just a little neater. Okay, so we have another condition here now. In the original problem, she now gets a prize money voucher. Okay, this is not a donation or something. It's not a scholarship or something like that. It's a voucher, okay, which she can say use at a bookshop or something like that. So, like, you know how you have these gift vouchers. So you cannot use it for just anything you want. You have to use it for that particular item or for that particular store for which you have the gift voucher. So she gets a gift voucher of 200 rupees, which she can spend on books, meaning only on books. She cannot use it for something else. So what happens to the budget line now? So now the question is, um, there is an extra 200 rupee voucher. So apparently her income has increased, right? So she had 2000 rupees budget initially, but now she also has a 200 rupee voucher. So now her income is a little bit more, right? Or is it, or is it not more? I'll give you a few minutes to think. What do you think it's going to be? Will the income increase or not increase? I just want you to think about that. And if it increases, is there some other condition also on it? Because it's an important point. I will of course solve it, but I want you to take a few minutes to think about what is happening in this scenario. Okay, so I just wanted to give you a few minutes to think. Let's draw this. So it's question 6, I think. So in this case, let me draw the diagram a little bigger because this is a messier diagram. Okay, so this was initially 5, this was 40. Okay, this is the same thing as what we had. I'm just joining this by dotted line. Hang on. Okay, so this was our original budget line. Okay, now what we are saying is that she gets an additional 200 rupees, which she can use only for books, right? So, how many books can you get with an additional 200 rupees? 0.5, right? And you may wonder how you buy 0.5 books, but you can assume that this is like data for like a extended period of time. So, we're taking some kind of an average over a few years or whatever. Because this is a weekly budget, right? So we are taking the data for several weeks and then we are averaging it out. So, so she can buy 5.5 books now because she has that extra 0.5 due to the additional 200 rupees dedicated specifically to books. But there is one more condition, which is that now she cannot buy 0 books because she has been given a gift voucher as prize voucher and she's not going to want to waste it, right? So even if you like think in real life terms, sometimes you get these Amazon vouchers or some restaurant voucher or something like that. Even if you were not initially planning to buy from that place, if you have a voucher, that's the human psychology, right? You don't want to waste it because it's free. So now her minimum consumption of books is also changed. Now the minimum consumption of books is 0.5. It's not 0 anymore. So let me draw this line also just to, mark how this is. But in the world of coffee, as far as her consumption of coffee is concerned, is that changed? It's not changed, right? Why won't it change? Because whatever extra income she has, she can only use it for books. She cannot use it for coffee. So the maximum amount of coffee she can have is still 40. Because even if she uses up all her money, she still has the same 2,000 bucks and the price of coffee is the same, so she can still get the same 40 cups of coffee. Now we want to explain this diagrammatically, how her income has changed, but without changing the consumption of coffee. So now because of the change in income, your budget line is now going to be something like this, because it has shifted outwards, but the consumption of coffee is not changed. So this thing just goes vertically instead of it going like, like this, as it may have originally. It's not going to happen. This part is not going to happen. This is not included. This part, this is not included. Only this part, which I have drawn in the blue curve, only that part is included in the budget set. This cutoff is there now, right? And let me shade this for better clarity. So this increase is there. You see, this is increase is there throughout the budget set because no matter what she was earlier spending on books, now she can spend 200 rupees extra on books. And it's only on books, not on coffee. That's why this whole income budget line, that whole line has shifted outward because no matter what she was originally allocating to books earlier, she can now allocate extra 200 bucks for that, right? So this is how your calculation is going to work out. Now let's take one example. If we know that she is consuming C is equal to 15, what is her consumption of books? So can you solve this? I'll just wait. I'll let you solve it. Okay, so somebody has solved it. Anyone else wants to try before I solve it? Okay, so let's write our original equation again. Price of books is the same. Price of coffee is the same. Now the income is changed to say 2200, right? Such that coffee is less than or equal to 40. This we know. And, uh, you know, every, and yeah, B is greater than or equal to 0.5. Okay, so now there are two conditions. C is less than or equal to 40. When we are saying that, we mean that that extra 200 bucks is not going towards coffee consumption. And when we say B is greater than or equal to 0.5, we are saying that she is mandated to use that 200 bucks voucher. Okay, so now let's plug in the values which we've got. I'm not simplifying it further. If you want, you can. It's the same thing. 400B plus 50 into 15 is equal to 2200. So you can just calculate this. Let me open the calculator. Come on. So I'm guessing you've done the same thing. It's not a question which I have already, so I don't know the answer. Okay, just give me a moment. This is yeah, so I solved it on a normal human calculator. I don't really like online calculators, so this comes out to be 3.625, which is I think what somebody else is also getting. It's pretty simple. You just simplify this equation, you get the answer. Now in this case, we were given the value of C and we had to calculate the value of B. But if you're given the value of B and you have to calculate the value of C, then there may be a slight difference, right? Because then we know that the budget allocated to C is only maximum budget allocated to C is only $2,000, not $2,200. Okay, now let's go back to our um, question. So this is the diagram, the same diagram which I just drew. This is, I think, looking a little neater, but I think I drew it properly also. So this is the diagram. Okay, next we go to a different kind of a budget equation. And I'll let you read the question and I'll mute myself. We'll take a 5-minute break here. And once I come back to this, if there's any other, actually, I didn't expect to finish this so quickly. So I'll need a few minutes to look up some other questions to discuss. So if you have any other questions you want to ask, now would be the time. I'm happy to answer. Otherwise, you'll just give me 2-3 minutes to look up questions from the book. Okay, so this is not from any book. None of these questions are from any book. These are questions which I made. So you won't find the answer anyway. You just think over this. This is a kind of a budget equation where the budget is the same, but the prices are depending on the quantity. So how do we tackle this? Okay, so let's come back to the question. So this is, I will take another example. I was looking for that question. Again, I have not solved that question, but I will explain. We'll solve it together after this question. So these are some examples where there is a difference in pricing of one good. Okay, so in this case, we have a baker and she wants to buy flour and fruits. Flour means the thing with which you make the dough. Okay, so that's flour and fruits for making cakes. Now, fruits have a costing structure such that it is 300 per kg for the first 10 kgs and 200 per kg after that, which means that no matter how much you're buying, first 10 kgs, you're always paying 300 per kg. Okay, so this part is important to understand. Even if you're buying 15 kgs, for the first 10 kg, you're still paying 300 per kg. And after that, whatever remains after that, which is the remaining 5 kg, for example, you're paying 200 per kg after that. The price of flour is the same. It is 50 rupees per kg, irrespective of how much you buy. And her total budget is, say, 10,000. Okay, so now you have to draw the budget line. And after drawing the budget line, you can also see how she might want to distribute her expenditure, for example. Okay, so did anybody try this question? No? Okay, so let's write down all the variables. Price of flour. Let's say flour is Y is equal to rupees 50 per kg. Price of fruit, which we're say taking as X, is equal to 300 per kg for X less than or equal to 10 and 200 per kg for X greater than 10. Okay, this is how we will write it mathematically. Okay, so for all X, you can say. I've added that for all X, meaning that if X is 15, then for every value which is less than 10, this is 300 per kg. Okay, now let's first draw the diagram, because from the diagram you can see how different things change in this setup. So just give me a moment. Okay, somebody has messaged something. Okay, that's good. I think hopefully you're getting the right answer. So we're taking fruits on the x-axis and flour on the y-axis. Now, if you want, we can just write the two budget equations. First is 50y plus 300x is less than or equal to 10,000. I is 10,000. You can write that somewhere. For x less than or equal to 10, and it's 50y plus 200x is less than or equal to 10,000 for x greater than 10. Okay, so this is the equation, right? Now what we want to do is, in both of these equations, if you want, you can just simplify it, divide the whole thing by 50. So, or you can just leave it, whichever way you like. I'm just leaving it as it is because I just want to first draw the diagram and then we can clean it up after we've drawn the diagram. So in the first case, the first part where x is less than or equal to 10, we get something like the y-intercept is going to be 10,000 divided by 50, which is 200. Right? And x-intercept is, say, something like here. It's 100 divided by 3. Let's draw this where? Let's draw this here. Right, this is the original curve. I'm just drawing it in dotted for now. We will draw a solid line later once we have drawn the whole curve. In the second case, the y-intercept is the same because 10,000 by 50 is still 200. X-intercept is different, right? X-intercept is what? 10,000 divided by 200 now instead of 300. So this is, say, 50 here. Okay, so this is for x greater than equal to 10. So let me also mark this value of 10 here because this is where the equation is going to change, and there should be a difference somewhere. 1 minute. Yes. So this equation, I think I'm missing something. Just give me a moment. I'm not wrong, but I think mathematically this should be slightly different from this. This is wrong. If you want, you can also write it in terms of flour and fruits. So here basically you need to change, okay, this equation will need to be modified a bit. Oops, sorry. So let's modify this equation to reflect that this is only for, so if you write it as it is, if you write it as we initially wrote, even though I wrote that for x greater than or equal to 10, it still doesn't sort of account for the fact that we have already spent that much money on x equal to 10. So for consuming, let's say, right, just like this, for consuming x is equal to 10, budget used is equal to, price of x was 300 into 10. So therefore 3,000 bucks is already used, right? Because remember, we are not saying that the entire, if you're buying 20 kgs of X of fruits, the entire 20 kgs is not going to cost you 200 rupees per kg. First 10 kg is going to cost you 300. The remaining 10 kg is going to cost you 200 per kg. So when you're saying that X is greater than 10, we are automatically implying that X equal to 10 has already been consumed, right? Only after that the new pricing starts. So when you have consumed X equal to 10, you have also used up 3,000 bucks from your budget. So now the remaining budget is now equal to 7,000, right? From 10,000, 3,000 bucks is gone. Therefore, you can say the new equation for x greater than 10 will be 50 50y plus 200. X is less than or equal to 7,000. Right? This will be 7,000 now because we have only that much budget remaining for this part of the equation to fan out, which means that the y-intercept is also going to change. That's how you get the kink. Otherwise, you won't get the kink. So, I mean, I know that this part is there in your lectures, but I'm just trying to show mathematically why there will be a kink. Because if you just draw the new curve, this new equation, without changing the budget, the y-intercept is not changing, right? Only the x-intercept is changing. So if you draw it, and we'll come to that example, if you draw it like that, then this becomes the new assume this is intersecting at 50, that becomes the new equation, but that's not what's happening here. I'll come to this part. I think if it's confusing for you, I'll come back to this part later. Let's just focus on this. So now the new y-intercept for this equation is 35, right? So this, let's mark this as 35. 35 only, right? 7,050. Let me make sure I'm not deciding. Sorry, 140, not 35. This is 140. Just 7,000 divided by 50. Yeah, I don't know why I took it as 35. So this is now the new x-intercept. This is the new y-intercept. Now you connect these two lines to get this budget equation. This is the new budget equation, right? And my curve is not coming out very proper because this point where they intersect should be 10. So let me redraw this. These are just difficulties your enemy is going to have when you draw these kind of complicated diagrams. So I mean, I'm doing all this in the class, but I will also encourage you to please do all this stuff on your own. Unless you draw it yourself, you will not fully understand how to draw it on your own if at some point you have to. Okay, so say suppose this is 50 and I draw this, say suppose this is 140 here. This is 50 and this is 10. Okay, this is a little bit more believable. I'm just trying to tidy it up. Now, these are two different budget lines, and we know that this whole thing is not, neither of these budget lines describes the whole budget. So we're going to draw out the part which we know is valid for different segments. So for x less than 10, we know that the original budget line is going to be valid. To make it thicker. Okay, so this part is valid for x less than 10, and the remaining part is this. So this part is valid for x greater than 10. That's why I marked the value x equal to 10 here. And put it in a different color. Okay, so this is now your diagram, and we can shade it again just to make it clear. So this whole thing is your budget set. Okay. So this is how you draw the diagram. Now, is this part clear? How we got this diagram? Somebody said something. Y50 on x-axis, shouldn't it be 45? Okay, why would it be 45? Let me check again. What did we do? 7,000. Why would it be 45? I didn't understand your question. I didn't see your question. I saw it only now, actually. So you want to answer? You want to ask me? Like you do? Do you want to explain your question? No? Okay. Okay, 35. Yeah, you mentioned 45, so that's why I was wondering where 45 is coming from. Okay, so yeah, this I'm just thinking if it should be 35 or 50. I think you're correct. It should. I didn't change that value. It should be 35. Because when we are changing the budget thing, it should be changed, right? Only thing I'm sure. So we have used up 3,000 bucks, and yeah, this is just an oversight from my end. This should be 35. Okay, you're saying that. Hang on. Right. Okay, this should be 45. Now I get it. So yeah, I think what she's trying to say is I didn't change the intercept for the x-axis after the changed equation. So this equation, in this equation, we are using it only when x is already greater than 10. Only thing I'm not certain, I've written this, but just give me a minute to think. 1 minute. Let me go back to the question. Yeah, so it will be 45 because what we have done is we have already calculated it based on the other equation for x less than or equal to 10. And in this particular segment, yeah, in this particular segment, in this segment from here, we are calculating it for x greater than or equal to 10. So, or we can, if this is becoming confusing, we can also split it as x1 and x2. So in the previous equation, you can just write this as x1, and in this equation, you can write this as x2, right? So this kind of quantity differentiation might make it easier. You can write this x1 and x2 is greater than. But if you write x2, then it cannot be greater than 10. X2 will be greater than 0 again. I'm just trying to understand how to represent it mathematically without it creating a confusion. Okay, let's leave it first how it was. Okay, so let's think. So say suppose now our remaining budget is 7,000 bucks, okay? And we want to buy 5 kilos of flour, right? So you have used up 250 rupees for flour, whatever way you want to pronounce it. And the remaining budget now left to you is 7,000 minus 250. This is 6,750. Now if you divide this by 200, you get 33.75. And right, this is the quantity. Okay, so I think you may be able to write this as x1 and x2, but only thing is then the notation will change. So in this equation, let me highlight. This equation is showing you the value of x after x is greater than 10. It does not include the value of 10, which we have already calculated before, right? If you want to change that, then you will have to write this equation differently if you want to write it all in one go. So there is another way of doing this actually. You can write this in a simpler way. So this is the equation we wrote by changing the budget. If instead of changing the budget, we change the amount, say, consumed for that particular good. So just give me a moment. I will just rewrite the equation in a simple way. So you can write it something like this. So this is the equation here, 50y plus 300x is equal to 10,000. This is equation 1. Now in the next equation, which is 50y plus 200, instead of writing x which we were using before, we can write this as 1 minute. This will not be correct. Okay, so I think there is a way to do this in a slightly more um, mathematically proper way. X minus 10, yes, you can write it as x minus 10. That's what I think the book, uh, I didn't find it in the book actually, but from whatever I remember, I think it's there in the book like that. But then you will not get the right budget, right? If you write it as x minus 10, you are taking 2,000 bucks as the expenditure, not 3,000 bucks, which is what you have spent, right? So that's the reason why you can't write it as x minus 10, because you understand what I'm saying. You're taking 2,000 on the right hand side instead of 3,000 what you have already spent. So you can write this. It comes out to be the same thing. If I write 200x minus 3,000, that value is okay. I'm just not convinced about writing this equation in this way, because this equation, if we write it in this way, it's not clear if you're referring to x after x, after including x equal to 10 or without including x equal to 10. And I think this is not there in the lectures. So I think this is where I need to look this up a little bit more, because the answer is right. I mean, this equation, this intercept will be 45. That is correct. But how we should write this equation, I will just need to think a little bit more about this. And was checking in the book, but it's not there in the book. So that is a little bit of a problem. Okay, apart from how we wrote this equation, any other constraint, any other problem? Because a lot of this stuff is going to be like more useful later when you guys study utility and preferences and all that. Right now, we're just doing the basic stuff of just the budget set. We've not talked about preferences and utility or any of that. So if anybody wants me to explain this part again, you can tell me. I can go over it. So let me discuss this other question which I wanted to discuss, which is a similar question, but in this there is a different, uh, slightly different problem. So let me read this out because I haven't typed out this question. So I will type it and I will update it in the lecture slides which I upload. But for now, let me just read out the question. This is a question from, this is Perloff, I think. Yeah, this is a question from Jeffrey Perloff, the book. So manufacturers often offer volume discounts to those buying large quantities of their products. How does a consumer's budget line change when a manufacturer offers a 10% discount on purchases that are in excess of 25 units? And how does it change if the discount is applied on all units when total purchases exceed 25 units? This is exactly the question which I was referring to earlier. Now, in the same question, if we modify things, I will come back to this equation. We don't know how to write this equation properly right now, but the answer and how we arrive at the answer is correct, I think. This part of the analysis is clear, I guess. So let's come back. For now, let's just assume that X we have written here includes 10 plus whatever else. Now let's come back to that part where we give volume discounts, and those volume discounts are on all purchases. So this part is where we were, forcibly saying that the first 10 units or the first 10 kgs are definitely going to cost you 300 bucks, right? But now there is a different question that says, suppose you're getting a discount. Okay, so she's getting a volume discount now. So if she buys fruits greater than or equal to 10 kg, all fruits cost 200. So it's no longer slab wise pricing. So in this case, we have a slightly different setting. It's similar to what we had before, but it's different in the sense that we don't have that kind of a kink now. So what were the intercepts before? It was 250, right? This was 200. This was 50. This was before we did anything. The original equation was 50y plus 300x is equal to 10,000. This was the original equation, right? For this, we got, sorry, not 50. This is 33.3. Okay, so in this setup, this is your budget line, right? But this is for any x only for x less than or equal to 10. For x greater than equal to for all x. For, oh no, let's not be for all x, but this one will be for all x greater than or equal to, not equal to. So at x equal to 10, let's just say she gets the same pricing, which is 300. For x greater than 10, she gets pricing of 200. So now it's pretty straightforward. Now you don't have the right side budget adjustment, because in this case, we are not saying that, she should have already spent, amount on buying 10 units of X or 10 kgs of X. Now we are saying that if she's buying X greater than 10, the whole thing is going to cost 200 rupees per kg. So now in this case, what is your new equation going to look like? 50y is equal to 10,000. This intercept is still 200. X intercept is going to change. Now this is 50. This is 50 now. This is by mistake what I drew before. This is now going to be 50, and or let me draw it solid also, it's fine. So now in this case, we need to know at what point the switchover is happening. Let's draw this in dotted also. So now x is equal to 10 is, say, here. This is x equal to 10. Now we know that, oh, this is not straight. Right, this is the point where the shift over is happening from one budget line to the other. Now we know that if x is less than or equal to 10, she's definitely on the original curve, right? So let's draw the original curve with green. She's definitely on the original curve if x is less than or equal to 10. This is equal to means it's including 10. Trying to make it thick. But if x is greater than or equal to 10, there is a jump, right? She's going to jump to this line here. And now this is going to be applicable. So there's no kink here, right? Now this budget line is going to be followed. Is this making sense? There's going to be a jump here. And that jump is because now we are applying the volume pricing. We're applying as in volume pricing, as in we're applying the volume discount. Because as soon as x crosses 10, now the whole thing is following a different pricing altogether. The whole thing is going to cost her 200 bucks. And why is there going to be a jump? Because this pricing is now applicable on the whole quantity. But if you buy less than 10, still the original pricing. You have these market pricing. If you buy something in wholesale, if you buy just one item, you get it for 50 rupees or something. But if you buy 100 items, you get it for 30 rupees or something, right? and you're paying for the entire thing as rupees 30 instead of 50. So this is what's happening. So in this part, x is greater than 10. You're still following the new equation. This equation is this part. And this whole equation means the whole budget is being used at the new pricing because the budget is not changing. So this is how the curve is going to change when you have, say, slabs of pricing. The first 100 units are costing you this much, or the first 10 units are costing you this much, versus if you have volume discounts. Like if you buy more than this quantity, you pay a discounted price of 200 rupees per kg. So instead of a kink in this kind of a situation, you're going to have a jump in the curve. And this part is actually, I mean, it's there in your lectures, but I've not seen any of your questions covering all this. So I'm already talking about some stuff which is slightly a little bit at the border of your course curriculum, but I thought it was an interesting question. So that's why I brought it to class. This equation part, I mean, this is whatever we've done is right. Just the I'm not convinced myself about how I've written the equation. So I'll relook at it and I'll come back to it. So if you have any other questions, you can ask me. Otherwise, just give me a few minutes and let me find one more question. And then I guess we can finish the class. Most of these questions are not complete. That's the problem. Most of the questions actually in this chapter are very simple questions, which you've already discussed. Okay, let me ask you this part. I think this might be, just give me a minute. You've not done indifference curves, that's the problem. Yeah, if you have questions which you couldn't solve, you can ask me. You can tell me, I will try to find the questions. Or if you can copy paste the question into the box, that will help. Actually, this whole part which we discussed today, it took us more than 1.5 hours last time. It took like 2 hours, something like last time. So I didn't realize it will finish quickly today. Okay, just give me a moment to open this. Okay, so this is, I think we discussed a question similar to this in one of the first few weeks. I don't remember which week. Okay, so I'll read out the question for those of you who have not read the question. It's there in the chat, actually. If you want, you can download it and read it. So the question says, Felicity is studying economics and pol science. She can read 30 pages of pol science per hour, but only 5 pages of economics per hour. Let me write down this part. I'm writing these as P and E. Okay, this week she has a 50-page assignment in economics and 150-page assignment in pol science. And this is what, 150, right? Yeah. Okay, because of sorority rush, she cannot devote more than 10 hours of studying to these subjects this week. Okay, she realizes she cannot complete all of her assignments, but is determined to complete at least 30 pages of her economics reading. She has, you can say, instead of income, you can just write this as budget. B is 10 hours. Okay. And she realizes that she cannot do all of it, but she wants to do 30 pages of economics. So 30E. So 30E means 30 pages is like how much hours? 7 hours? Sorry, 6 hours. She's doing 5 pages per hour. Therefore, 6 hours to economics. That leaves her B minus 6 is equal to B prime is equal to 4 hours. Okay. Draw a graph with pages of economics on horizontal and pages of pol science on the vertical axis that show the possibilities that are consistent with the constraints that Felicity has imposed on herself. She's allowed to read ahead in either subject, label key points, blah, blah, blah. Okay, so now in 4 hours, how many pages of pol science can she read? She can read 4 into 30 is equal to 120 pages of P in given time. Right, so let's draw this. You have what is on what axis? 1 minute. Economics on horizontal axis, okay. And P. So let's say the rate at which she is reading the pages or reading the book or whatever it is, you can think of that as the price, something like a price, right? And the number of pages is like the quantity in, if you want to reduce it in economic terms, right? And the number of hours she has is like her total budget. So if we know the rate at which she's reading, you can write this as let me just make this as an arrow instead of equal to sign, so it's not confusing. So you have 30 pages per hour. So let's write 30p, or 1 by 30 actually. You can just give me a minute, because you're saying this is pages per hour, so that is not really the price. That is like the one of inverse of that will be the price, because in 1 hour you're reading 30, in 1 hour you're reading 5, right? So the budget we know is 10 hours. Quantity, we can say the number of pages, and you can say that hour per pages is the price, right? Does this make sense? Why it will be hour per pages? Because the constraint is on hours, right? Pages, you have to read a certain number of pages, but she has only limited amount of hours. So how much time she's dedicating to each subject is like the price, right? So if we are given the rate at which she's reading, but if you take, inverse or reciprocal of that, that gives you hour per pages. Let me write this a little correctly. 30 pages per hour, right? Similarly, this is 5 pages per hour, right? So this, now you can write the broad budget equation, which is, you can say P by 30 pages of P plus E by 5 is equal to B. Does this make sense? This pages cancels out, hour remains. The total equation is in the units of time, which is hours. So this is your broad budget equation. Now you can draw this on the diagram, but you're given also some kind of constraints. Now what she has to do is in terms of quantity. She needs 50p and 50e and 150p. She needs to finish that, or she needs to consume that. So she needs to consume 150p and 50e. We are saying consume because that's like the economic terminology. But what we mean to say is that she needs to finish 150 pages and 50 pages respectively of pole science and economics. The rest, let me open the question again. Yeah, so now she's basically saying that she cannot complete all of her assignment, but she wants to complete at least 30 pages. So that is the constraint she has sort of self-imposed, right? Self-imposed constraint is 30E, which means E, I'm writing it as 30, E 30 of E, maybe we can write. So E is less than or equal to 30. Okay. I don't really know how to write this better in notation terms, but I think, I hope you can kind of understand what I mean by this. Let's first draw this diagram. So in this B, let me plug in the value of B. B is 10. She has only 10 hours, right? So E becomes 50, right? And P becomes 300. So this is her broad budget line. So if she dedicates all the 10 hours to economics, she can read 50. But she has imposed a constraint on her own self that she does not want to read more than 30 pages of economics. So then this becomes like the new constraint or the new upper bound on economics. So that's, I think, one of the things they have asked, that she's allowed to read any amount in each subject. It's not that she cannot read more than that, but it's a constraint she has imposed on herself. So even though 50 is the upper bound, if she wanted, sorry, it's not at least. Oh, wait a minute, let me read the question again. She realizes she cannot complete all of her assignment, but she wants to read. Oh, right. Yeah, sorry. This is at least. I thought it the other way around. 1 minute. Okay, so she has imposed the constraint that she wants to read. Right. Sorry. This is greater than or equal to 30. So this is the point where she is going to read at least 30, means that E is going to be greater than 30. It can be up till 50 because she cannot read more than 50 pages anyway. Because in 10 hours, that is the max she can do. And her assignment says that she needs to do 50 pages of economics and 150 pages of pole science. So now, if she reads 50 pages of economics, she cannot do any quantity of pole science, right? But if she does 30 pages of economics, I think, did we calculate it? No, we can calculate it from this equation now. If E is equal to 30, P will be what? We can just calculate it by plugging it in this equation. P by 30 plus 35 is equal to 10, right? Yeah. Okay, so P by 30 is equal to 10 minus 6 equal to 4. We got this value as 120. Oh, we calculated earlier, forgot. So we know that the best she can do is do 30 pages of economics and 120 pages of pole science, or she can do only 50 pages of economics, no pole science, or she can do 300 pages of pole science and no economics, or she can do any combination of the two, which falls in this diagram area. So we are saying that she has said that she wants to do at least 30. So, the upper the lower bound of E is 30. So this much is definitely going to do. And apart from that, she can do all of this also, right? If she's constraining herself to 30 pages of economics. But if there is no constraint, if she does not want to follow any constraint, then she can use up this whole budget set. This is your whole budget set. So the budget set itself does not have a constraint, but she knows that she cannot do both the things. She cannot do 150 pages of pole science and 50 pages of economics, because that is outside her budget set. So let me see, what was the question again? Anything in the triangle bounded by 0, 300, and 300, 120, and 30, 0. Yeah, so this part we calculated is 120. Okay, I think this answers the question. Did you get a different answer, or was there like some place where you were stuck? Does this make sense? I think this is what they're saying is the answer, right? Basically, you want to see whether she wants to follow the constraint or not. So what is the answer they've given? There may be something wrong in the answer also. 30, 0. I mean, 30, 0 is this point, right? This is 30, 0. And 0, 300 is this point. And 30, 120 is this point. So this is what they have said. But this, I think maybe they have made a mistake in writing the answer. Maybe it should be this point, right? So this is what she has, the triangle we have highlighted is what she has imposed a condition as on her own self, but it is not necessary for her to follow that condition. If she wants, she can follow this whole triangle, which I highlighted in yellow. So that's the thing, actually the question itself is not that obvious as to which part they're asking, but this is the solution. I don't think the solution will be different from this. So if you got this answer, then I think you're correct. Also, yeah, so if this is from Varian, I will check up the book and I will look up and I'll see if there is something there. Generally, it is not normal for solutions to Varian to be different, but it depends on whose solution it is. If it is a solution given by somebody else other than Halvarian, then there may be a mistake. It's always possible. It's a test file. Okay, so the workbook has the answers usually in the back. So if this is not that, then yeah, you don't have to worry about the answer because I think it's wrong. If you understood the whole approach and the rationale, then I think you've got the answer correctly. Okay, so there is one more question which is there in this book. Let me see how much this is. So I think if you don't mind, I will solve this question in the beginning of the next class because we're almost out of time and I'm kind of coughing a lot. And I will also look up the answer to this one if I find it somewhere. Is that fine? Or do you want me to solve this now? Because it will take me at least 15 minutes to solve the next question. All right. So I think we're done with the class, and maybe in the next time I'll bring extra questions so we don't run out of questions in the middle of the class. It's just I timed myself according to the previous class. Okay, so I will see you all the next time, and I will update this question also in my slides when I upload them and the whole working. So this equation, which I said that I will check it, if I find a slightly better notation for this, I will update this file and then I will upload it. Okay, so we have a better understanding of notation also in this. Okay, thank you everyone for joining, and I will see you all next time.